The internal combustion engine is one of humanity's most transformative inventions, powering billions of vehicles across the globe every single day. But have you ever wondered what's actually happening under the hood of your car? Today, we're taking you on a detailed journey inside the modern car engine, breaking down its complex systems into understandable concepts. We'll start by exploring a typical four-cylinder engine, the workhorse found in most passenger vehicles. This compact power plant contains hundreds of precisely engineered components working in perfect harmony. At its core, the engine converts chemical energy stored in fuel into mechanical energy that propels your vehicle forward. Through controlled explosions happening thousands of times per minute, pistons move up and down, turning a crankshaft that ultimately sends power to your wheels. Modern engines are marvels of engineering efficiency, incorporating advanced materials, electronic controls, and aerodynamic designs. Whether you're driving to work, embarking on a road trip, or simply curious about automotive technology, understanding how your engine works will give you a deeper appreciation for the machine that gets you where you need to go. Let's dive into the heart of engine operation, the four-stroke cycle. This fundamental process repeats thousands of times every minute in each cylinder. First is the intake stroke. The piston moves downward while the intake valve opens, drawing a precise mixture of air and fuel into the combustion chamber. Modern fuel injectors spray atomized gasoline directly into this chamber with incredible accuracy, measured in milliseconds. Next comes the compression stroke. Both valves close completely, sealing the chamber, and the piston rises rapidly, compressing the air-fuel mixture to a fraction of its original volume. This compression is crucial. It dramatically increases the mixture's temperature and energy potential. The compression ratio, typically between 8:1 and 12:1 in gasoline engines, determines how much the mixture is squeezed. Higher compression ratios generally mean more power and efficiency, but require higher octane fuel to prevent premature detonation. The camshaft, driven by a timing belt or chain, precisely controls when valves open and close, coordinating perfectly with piston movement to ensure optimal engine performance throughout the entire cycle. The power stroke is where the magic happens. At the precise moment of maximum compression, the spark plug fires, creating an electric arc that ignites the compressed air-fuel mixture. This controlled explosion generates tremendous pressure, forcing the piston downward with tremendous force. This is the only stroke that actually produces power. The other three strokes consume energy to prepare for this moment. The expanding gases can reach temperatures exceeding 2,000 degrees Fahrenheit. The connecting rod transfers this linear piston motion to the crankshaft, which converts it into rotational energy. Finally, the exhaust stroke completes the cycle. The exhaust valve opens, and the rising piston pushes spent gases out of the cylinder. These hot gases exit through the exhaust manifold, passing through the catalytic converter which cleans harmful emissions, then through the muffler to reduce noise. The engine's electronic control unit, or ECU, monitors dozens of sensors and makes real-time adjustments to optimize this cycle. It controls fuel injection timing, ignition timing, and valve operation with incredible precision, adapting to driving conditions, engine temperature, altitude, and throttle position to maximize both performance and fuel efficiency while minimizing harmful emissions. Modern engines often incorporate forced induction systems like turbochargers to dramatically increase power output without increasing engine size. A turbocharger uses exhaust gases to spin a turbine at speeds exceeding 100,000 revolutions per minute. This turbine drives a compressor that forces more air into the cylinders, allowing more fuel to be burned and creating significantly more power. The intercooler, positioned between the turbocharger and engine, cools this compressed air, making it denser and even more oxygen-rich. Turbocharged engines can produce 50% more power than their naturally aspirated counterparts of the same displacement. Speaking of naturally aspirated engines, these rely solely on atmospheric pressure during the intake stroke, offering linear power delivery and simpler construction. Diesel engines operate on similar principles but with crucial differences. They compress air to much higher ratios, sometimes 20:1, generating enough heat to ignite fuel without spark plugs. Diesel fuel is injected directly into this superheated air, auto-igniting and producing tremendous torque. This explains why diesel engines excel in trucks and heavy equipment. Understanding horsepower and torque helps explain engine performance. Torque is the rotational force the engine produces, while horsepower measures how quickly that force is delivered. Critical support systems keep engines running reliably for hundreds of thousands of miles. The cooling system circulates coolant through passages in the engine block and cylinder head, absorbing heat and transferring it to the radiator where airflow dissipates it. Without proper cooling, engines would seize within minutes. The lubrication system pumps oil throughout the engine, creating microscopic protective films between moving metal surfaces, reducing friction and wear. Oil also helps cool components and carries away contaminants. The oil filter removes these particles, keeping the lubricant clean. To maintain your engine's longevity, follow these essential maintenance practices. Change your oil and filter according to your manufacturer's recommendations, typically every 5,000 to 7,000 miles for conventional oil, or up to 10,000 for synthetic. Replace air filters regularly to ensure clean airflow to the engine. Monitor coolant levels and have the cooling system flushed periodically to prevent corrosion and overheating. Keep your fuel system clean with quality gasoline and occasional fuel system cleaners. Listen for unusual noises and address issues promptly. Modern engines are engineered for remarkable durability, but they require proper care. By understanding how your engine works and maintaining it properly, you'll enjoy reliable performance for many years to come.